we talked about all those necessary elements that it's a must, no choice. You must include them in your map. And you can see my map right now. I'm assuming that, let's say you put some effort, you finish all the line work. I'm talking about, the model space. So you have drawn all the roads and fences and so on and so forth. So you're done, 100%. Then then you can see here, this is not yet finished. We have to add few things more. I tried to make your life easy, so I kind of came up with the legend for you. All you have to do is ensure that your map follows 100% the legend. We've done this already. And we have a map title. So in general, map title, for example, like Cedar Break Community, or maybe State, or maybe Calgary map. So every map comes with a title. So you need to have a title. In this exercise, maybe you can call it Tahir map, or assignment number 2 map. Just give it any title. And down here, there is a two placeholder, which is empty. Those are empty. So we have a place for the date. The date supposed to be the date of which you made the survey. Just you can make it as the date of your submission. And for the scale, I have done all the effort for you. So all you have to do is just type in here 1 to 2000. In general, guys, look at this. The scale, it depends on the area, the size of the area that you have done. And also it depends on the size of the paper. Couple of things to determine what should be the scale. It depends on, for example, this area is 500 by 500 meter, and I want to present this 500 by 500 on an A3 or A4 or A0. Remember, those standard paper sizes, they have a size in millimeter. So this is scale. I have done this effort on your behalf, and the scale, if you go back to the model space, the scale is already 1 to 2000, and that's why I ask you to work on the template, because everything is set. And also what I did is I also logged the scale of the layout. I need you guys, but please do the following, because I feel it is very important. Although I have done it on your behalf, I want you to go back and learn and remember, how can I create a new layout? How can I create a new layout? So it's not very difficult. When you create a new layout, you just have to set the right paper size, and also you have to set the right scale. Okay? So just please, I've done this already for you. You don't have to do again, but I'm asking you to do that, to go and review how can I make a new layout. Okay? So I have done the layout, and I also logged the scale, so you don't have to play with the scale. So I logged it, so it's logged here, so you cannot change it. And let's go ahead and add those things. For example, you can see once you go from the model space, so on the model space, there are some ribbon here. If you just go ahead and go to the layout, you will see there are the stuff that you want to add. I'm going to start here with the north arrow. So on the ribbon, there is a north arrow, which when you click on the north arrow, simply it opens for you this dialog box, and you can see there is a library where it has probably about 30 different arrows or arrow graphics. Let's make it simple. Let's say I'm going to use arrow number 9. So once you click on arrow number 9, it tells you select the viewport. You guys also need to remember, what does it mean, viewport? Viewport is the window that you open from the layout to the world. Okay, so the viewport is here. This square here or rectangle, this is the viewport. So once you click on the viewport, you're able to click anywhere else on your map, and it drops for you a north arrow. The only thing which I'm not sure why this is happening, the north arrow will be super tiny. You need to zoom in, and you need to stretch it to make it large. So you click on the north arrow, and then you have a handle, and you can see if I grab this handle, see what happens. I'm kind of stretching my north arrow. You zoom out and you keep stretching until it become a reasonable size. Okay. For example, this way you can see, here is my north arrow. Okay. Number two, after you add your north arrow, number two, you can also add the scale bar. The scale bar. So let's go ahead and click on the scale bar. You just wait for a second, and it again the same thing. It will open for you like different shapes of the scale bar. All I'm asking you is to use metric, because there are some designs are imperial design like so. Please anything metric. For example, I will use scale bar 3 metric. You click on it one one more time. It will ask you here on the command line, select a viewport. Select a viewport. So what you have to do one more time, you select your viewport, and then next is you simply don't change the scale, because the scale is set. It is 1 to 2000. Maybe you want to change the division into, let's say, 50 meters, and then so it means you have a division on your scale every 50 meter, and then hit OK, and then you can see here is my scale. You just put it here, and it says you can see here is 0, and then 50, and then 100 meters. Okay, then the last thing I want you guys to do is simply a reference system. So typically in surveying drawing, we had something called grid. We place here a grid line, and we need also to show some coordinates. We do not do that manually. We do not do that manually. So what you have to do is you just go to reference system. So we've done the north arrow. We also have done the scale bar. And then lastly, we will go ahead and then add a reference system. Reference system. Okay, so you click on the reference system, and one more time, what is asking? Look at the command line. The software is asking you, select for me a viewport. Which one of these line work is your viewport? It is this guy here. As I said one more time, please take your time. Check, maybe there are some YouTube videos to check how can I create a new layout. And together with the layout, is they are very connected. How can I create a new viewport? They are very connected, huh? If you remember. So I click here on my viewport. Next is the software will ask you a couple of things. Number one, the scale. Please don't touch the scale. The scale, I fixed it already, 2000. However, here is asking about precision. But to be honest, I don't know why Autodesk like name this as precision. This is simply the grid spacing. The grid spacing, like between those lines, what is the spacing? So please use 100. Use 100 meter. I'll show you after I apply it, what does it mean 100. So precision is not really the precision or accuracy. Precision, that's the distance between the grid line. Watch this, please. Watch this as I hit OK. See what happens. The software automatically, what it does, it simply blazed for you the grid lines, and the 100 is simply the distance between the grid lines. So this is 100 meter, and this also 100 meter. Okay, together with the grid lines, you can see there are some coordinates like 102 to 100. Those are the coordinates. And the only thing I need to remind you that when you plot, make sure that you are able to see the grid line coordinates, like these numbers. You can see, for example, this guy is out, so you want to click on this guy and move it a little bit. Why move? Can you tell me? Anybody tell me why should I move it?
It won't be printed up.
Exactly, because this dashed line here is the border. So this is the border, and simply those numbers outside the border will not be printed. It's very simple. Look at this, please. So all you have to do is you simply have to click on this and simply move it up inside your title block, and simply you're good to go. Same thing on the top. On the top here, you simply have to like select them and then move them down so they become printable. Okay, just like so. Okay, like so. Now we can see here is our final step. There is one step left, only one step. Now we can see, am I asking you guys, after you finish your assignment, am I asking you to send me your CAD file? I need yes or no, please. And if anybody read the assignment, am I asking you to submit your AutoCAD file?
No.
No. If you read the assignment, really what I'm asking you is, after you put all the information, put your name and everything, you need to give me a PDF file. Because really, whenever we went to the class, I asked my students to print it on a piece of paper. Right now, there is no piece of paper. You cannot just mail it to me. just please print a PDF file, and I will show you in details right now how to do that. Okay? So please, for everyone, I don't need your CAD file. I need only your PDF. Only if I see suspicion in your drawing, because I have some rules to do that. If I see something that is fishy, I will ask individuals, not all of them. I will ask individual to send it to me. If I don't ask you for your CAD file, don't send it to me. If I email you and say, let's say John, okay, John, send me your CAD file. This is the only time you send me your CAD. However, on the D2L, please submit a PDF file, not your CAD. Now, before I show you the printing, which is easy process, because I made your life easy. To be honest, I put a lot of effort for you so you guys can minimize your effort. Okay, because I've seen over the years, if I don't do that, students, they get lost and they cannot finish their assignment. Okay, so there are a couple of things I want to do before before I show you the printing, and those things are available on the assignment. So if I go back to the assignment, you can see here is the assignment, and I will go to the part that I kind of ignored for now, which is requirements. So please take a read, and it says here, produce a map for the given site, submit a PDF. Watch this, huh? Submit a PDF. That is what I want, okay? And print the map on A3, and then on A3, landscape, scale 1 to 2000. Uh, all of that is just a matter of one click because I have done all this effort. I set up, when I made my layout, the paper to A3, I set up the scale, so it's a matter of one click. You will see this in 5 minutes. However, however, uh, I said here, which I said it already. However, a student is highly advised to review how to set up a new layout. I think I have a typo here. A new layout, not new out, new layout. Okay, so this should read new layout. Very important for you guys. Very important. Also, please remember how to make a dimension style and font style, and make all of them annotative to about 3 or 4 millimeters. Now, on the building, on number 2, on the building, please show 5 dimensions. So I want you guys to measure and dimension the building. I need 4 sides and 1 diagonal. I'll show you this right away, okay? Dimension line should be red and should read 3 decimal places. So let's do it right away. I'm gonna show you how to do number 2, which I'm pretty sure that you can do that on your own, but let's do just in case. So if you go back to here, you go back to here, I'm asking you, show me or dimension your building. So there is a command line called dim, which is create dimension line. And I think I use aligned, so letter G. So all you have to do is you pick one line here, line dimension from on this line here, and on this line here, and okay, and on this line here. Okay, so the thing is, look at this, please. The dimension line is super small and it's ugly, and you know, the arrows are small. And look at this, how many decimal places we have? 4 decimal places. Now the question is, what do you think? Is that what Tahir asking? If you read the assignment, I need you to know a little bit on how to change dimension style. I will show you how to do that. I go GDim, not dimension, GDim. And if you go GDim, you're able to simply look at the style and simply change it. So you can see this is the only style I have right now. I will go ahead and modify my style. You have control over everything. For example, if you go to the symbols and sorry, to the arrow, to the units, you can see here, this is the how many decimal places. According to the requirements in the assignment, I ask you for 3. So drop this menu, ensure that you have 3 decimal places. Okay, so that's one thing. The other thing, if you go to text, what you have to do is you look at the text and you will see the text is right now is black. I can make my text red. And then also in the text here, you will see it follows text style standard. So this guy is a standard. So I need to go and make sure my standard is minimum of 3-4 millimeter, and it's annotative. Okay, so let's hit OK for now. Let's hit OK for now and see what happens to my style. I think I don't know, like there is something called dimension update, but if you have done this, the change after you do the dimension, all of them they will have to follow. I'll just erase my dimension. I'll do it one more time, and I know now they will follow the new change. Okay, watch this, please. So look at my numbers right now. It's red. It's 3 decimal places. As soon as I go to style and I make my standard style, standard is here. I should make it annotative, and also I should make it, let's say here, make it like 4 millimeters height. So now I can say apply, and I close. And if I go to my model space, they're supposed to follow. Okay. Also, I think I'm asking for create point table. Okay. So create point table. You guys remember last class how to create a point table? And remember that the table is not for every point in your drawing. The table is only for the traverse point or the control point. So just quickly, let me remind you on how to do that. You guys, we go to the model space. We go to points. We go to add table. And as you guys remember, we just leave the style as is, and then we'll change later on. I'm going to go and pick a few of them, which is this one here. Don't pick everything, please. Just go ahead and say, you know what? Here is C1, and then C2, and then C3, and then C4. Okay, only 4 points. I need a table for the 4 control points. When you're done the selection, you just go ahead and hit enter, and this opens up your drawing one more time. Now I need to hit OK, and then simply place my table anywhere you like. Try to avoid to place it on top of your drawing. That's wrong. Just stay away from your drawing and then place your table. Now, once you go to your model space, you will see the table is there and looks like it's cut, huh? So probably you have to move it a little bit to the east to get it in the drawing, huh? So you go back here, take this guy, move it a little bit to, move this guy a little bit to the east, and you go back to the model space so you can see here is your table. Now you guys remember that, sorry guys. Now you guys remember that in the assignment, I ask you to follow a specific format. Please take your time, read it, please.
Up to 3 decimals in green color.
Exactly. So you can see I ask for a very specific format. Use point table format as point number, easting, northing description. Don't show elevation because all the elevations are 0. So there is no point them to show them. Number 2, show easting and northing through 3 decimal places. Number 4, make it green. I will do that, all of that right now. Watch this, please. I'll go ahead, click on the table, right click, go to table properties. Then I will make a copy of the table format or table style. Copy, change the name first. I'll call it Tahir format, Tahir table format. Next is I go to data properties. Then number 1, I will mark my elevation and then delete. So delete the elevation, no need. And then I'll go change the precision. You guys remember how to do that. I click and then I delete. Then change 3 decimal places. Then make sure you copy everything back. Hit OK. Also for the easting, I go here, I click, I delete, I change to 3 decimal places, and then copy everything back. Hit OK. And then last thing you want to do is, if you guys remember from last class, what is the last thing you want to do? Is the order. Because there is a bug in the software. If you start with changing the order, it will reset itself back to this one here. So go back to easting. So drag and drop, and you can see point number, easting, northing, description. Let's go ahead and hit OK, and then hit OK. And then you can see here is your file format or table format. So we have easting, northing, no elevation. And if you wish, you can change, for example, the point table into something like, watch this. So I'm going to edit the table one more time. This time I will not copy because I already copied my style rather than just editing the style right away. And remember, all you have to do is come here, double click, and you say traverse point coordinates, and then hit OK, and then hit OK, and then hit OK. And here we go. Here is my table. If I go to the layout, you can see my table is over there. Beautiful. Okay. But just please be mindful. Something like that. What do you think? Is that a good idea or bad idea? Like, look at this. So my grid line is just on the 5. So you think about it, you will see maybe while on site, maybe someone will interpret this as 6, not 5. So I would say I can go here to the model space and I can move this guy very quickly a little bit, not only the text, but the whole thing a little bit to the right. And I think problem solved. Let's go back to the paper space one more time. You can see I have kind of avoided to the grid lines. Okay, so now let's go to the last part. Probably we'll conclude our class with the last part, which is printing. Now you're ready. Let's say you've done everything. Everything is ready for printing. So what you have to do is you just say either print, you type in print, or plot, or even control B. All of them the same. So whether you say plot, so that's one thing, or print, or control B, or if you don't know those, all those, you can come here to the file and say file. Somewhere here it's supposed to have print or plot. So I'm going to show you what to do right now. So let's say control B. I'm going to the printing. Now, as I said before, this has been already done on your behalf. And I know when I left it for my students, they had hard time. Because right now, because I set up my layout, so what are you printing? You're printing a layout. So which means, and everything is set up, like the A3, the size of the paper, the scale is, everything is set up. Okay. And so next is, remember, anybody guys in this class know what does mean bin assignment? Anybody in this class remember from last year, what does it mean bin assignment or plot table style?
A monochrome for color printing.
Exactly. So this option here in CAD is very handy because if you print all the line work with the same thickness and the same depth of color, it's not, your map is not easy to read. For example, watch this. I'm asking you the grid lines. What do you think about the grid lines? Those grid lines, they should be heavy or light?
Light.
They should be very light. Okay, so because they should be very light, so what happens? We control this through bin assignment or plot style. How we do it? Simply we look at the color. For example, the color is white, like this is like number 7 in CAD, and in my bin style I make this is very thin, very thin. While something like the road edge, like this blue here, I will make the blue as heavy color, like thick, so this will print thicker on your map. That is how we make our map beautiful. I need to remind you, please mindful. What do you think? Is that something nice, what I did? My text and my grid line, the overlap. So please be watch these things. Try to print your map in PDF. And once you print your PDF map, then go around, make sure the things are legible and is formatted the right way. Okay. Now, as I said, finally, Control B. I saved you a lot of effort because I kind of set up everything for you. But please, as you review how to create a layout, also review on how to save this plot style. Okay, so you can see here, I'm not really printing a window or extend or display. I'm printing the layout. Bin assignment one more time. If you go here and say edit, you can see here every color has a thickness. Every color has a thickness. So I've done this on your behalf. For example, the blue, it's 0.2. The black, it should be It should be very little. Should be very little. Let's say 0.05. If you do so, what does it mean? It means your grid line will become very light. It doesn't take your attention when you read the map. Okay, and then save and close, and then finally you hit OK. So when you hit OK, it simply will ask you where you want to save your map. So you will call it here, for example, Tahir Hassan. Like, let's say that's your assignment. So Tahir Hassan, and then assignment number 2, assignment number 2, and then say save. And we'll save a PDF file, and here we go. Here is my map. Beautiful, beautiful. Okay. Any question for now?
Did you end up clicking monochrome, or did you leave it as ACAD?
I leave it as a CAD, and I don't want you to change it, because if you change it into monochrome, what happen is it's going to print as like one color, like degrees of gray. Right. Before, in the past, this question was valid. Like when I asked them, my students, when we were in class, could you please print me a physical map? So it makes a difference, because simply some of them they print in color, some of them they print in a black and white printer. But right now, since the submission is simply everything is digital, so I would say leave it as color, like CAD. Any other question? Because we still have time, so I can cover other material. Any other question before we proceed? Okay, so again, the assignment, to be honest, the assignment, okay, sorry, go ahead.
What about the area of the building?
The area of the building, that's on number, I guess, number 3. So in CAD, there is a command called the area. I'll show you here. So if you go to the model space and simply you want to find the area, so all you have to do is there is a command called area, and then you can measure the area based on object or entity. You can say E for entity, and then once you pick this polygon or polyline and go to F2, so it simply tells you here what's the area. So the area here is simply 9,664.454. So all you have to do is you simply write a text here, like text here, a text, and simply you will say building area equal, like let's say 9,664.64 meter square. That is really what I want, and then hit OK, and then you move this area, move it here. Okay, that's it. That's what I wanted. Again, this is too big, so probably you want to do some makeup, so you want to move it this way, so it's more legible, like for example, like so, and move it inside your building like so. Any other question before we handle the next part? You know what? It should be a very straight assignment, but I really advise you to review the skills as per the assignment before you start. You will have to combine those skills with your CAD skills that you learned last semester. And again, if you have any question, you know what to do, If you have any question, you can ask me for sure. Now, let's say we're done with this assignment for now, and I'm going right now to show you another topic, which is about contour map. And I know contour map is not new. Last semester, I think, or last year in your first year classes, you learned a little bit about contour lines. So we have to take this discussion and then expand and build on it. Okay. And I'm not going to do the whole thing today. The discussion about contour lines and surface models will start today, and probably will go for about 4 hours. So I think for the entire next week, we will talk about contour lines and how can we build them and customize them and so on. All those details about contour lines will be covered next week. Okay, so for today, We have 4 elements, not really today, not all of them. However, I can tell you the agenda, which we can start today and we can finish next class. So we're gonna remind you. I know that this is a just reminder, because I know that either last year or maybe in your high school you learned about contour lines. We also, I will try to give you some tips on how to read contour maps, because I can tell you, I would say any CVT students must be able to read and interpret contour lines, which is not really very difficult. You will see there are some rule of thumb that once you learn them, it gives you an understanding of the ground. And I can tell you most of them, they are very intuitive, which means some of you even are able to read contour map maybe even before this discussion. But let's confirm that, okay? And then we talk about contour line properties, and then finally we will show you how to draw contour lines manually. That's for the class. And then once this part is done, I will spend sometime next week to show you all the details about contour lines in Civil 3D from A to Z, okay? So I always start from here, always start from here. So what are those contour lines and what they do for us? So that's why I ask my students, just look at my screen, and on my screen, there are 2 different graphics, two different representation, the top one and the bottom one. Now, the first question is, do you think those 2 different views are for the same area or for different areas?
Same.
Same area. This is not really very difficult to see, although those are 2 different representation of the ground. However, it's not very difficult to see that they are for the same area, and there is a correspondence. So everything on the top view you can recognize and identify on the bottom view. So let me tell you, the top one is simply something called 3D, or sometimes called iBird view. It's a render. And it is relatively new. Although there are lots of trials in I would say hundreds and hundreds of years to draw stuff in 3D, but this render where you can rotate and zoom in and zoom out, it happens only when we have computers. Okay, so this is called 3D view or iBird view. Easy to understand. Any little kid can look at this and understand where are the high areas, where are the lower areas. Anyone, any human by nature, they are able to interpret the 3D. The bottom one is different. The bottom one is a contour map. A contour map. And the contour map is not new. It has been used for a few hundred years, and it's very old technique, but not everyone is able to read contour map and come up with understanding of how the ground looks like from a contour map. You need some training. While the top one is, you don't need any training. Anyone can look at this picture and understand where are the low areas, where are the high areas, where are the steep faces, where are the mild faces, and so on. Now, I want you to show you something very important. Why contour map has been used for so many years? Because simply you can draw the contour lines on a flat piece of paper. The top one, to create the top view, you need a computer to render for you the 3D, and which is only available, I would say, maybe 40, 30. Since the invention of the computer, people, they try to make advancement with graphics. Now we have fantastic software, and we have really powerful machines to be able to render things in 3D. Amazing for sure, but the contour lines is very old. And remember, contour lines are plan views. So the contour map can be drawn on a piece of paper. However, from the contour map, although it's flat, but just by drawing contour lines, you can see heights. I want to get someone to confirm, please. Contour map can be drawn on a flat piece of paper, but by looking at the contour map, we can find heights and we can visualize heights. We can get understanding same understanding on the top picture just by looking at 2D paper. Would you guys agree or disagree?
Agree.
Okay, so just want to mention something before we proceed, that this was kind of a common problem that designers and so, by the way, so you know, it's not only designers. There are so many people, even for gaming, they want to look at something where they can see in 3D. That's very, very common problem, okay? Maybe to connect you to our field designers. So when somebody is trying to design a road or a highway, they would like to see the change of the existing ground. To do so, we have many products, not only one product, okay? One of those products probably some of you are familiar with is a contour map. So please look at my screen on the left. So what is on the left? What is on the left is a contour map. We will talk about in more details about this thing on the left, about contour map. But when you learn from me on how to read contour map, you will be able to kind in your brain to build a 3D understanding of how it's happening or what's happening in this area. Where are the steep faces? Where are the mild faces? And so on and so forth. Okay? Now, I want everyone to look at the picture on the right. The picture on the right. So the picture on the right is that contour map. It is not a contour map. I'm asking you, can you read and interpret the ground from the one on the right? Can you kind of understand, like there is a kind of lower area, higher area, there is a steep faces, there is a mild faces or slopes?
Yes.
Yes. So this thing on the right called hill shade map. And so you know, this is for SAIT. If you pay attention, this area is part of SAIT. And so if you have been to SAIT, I know that you have been to SAIT. So this is the soccer field. This rectangle is the soccer field, and the one on the road that's the 10th Street, going from the south to the 16th Avenue on the north. So this area of SAIT, really my point is, everyone wants to understand the topography. However, the tools are different. So we can use contour map or we can use other product. In my class, at the very end of our course, I will show you how to create the one on the right. The one on the right will be created at the very last of my class. However, you know, shortly, starting next week, I will show you how to create the one on the left, which is a contour map. Okay, so now what is contour map? Like, what is contour map? So contour map or contour line is an intersection of the existing ground or the ground with virtual planes. So we kind of cut my ground with some virtual planes. Those virtual planes, they are on my screen here. So let's start with the bottom. So please, for now, please, forget about the top picture. So the top picture is your final product. We start here from this, and this one, what is this? This is an elevation view. So we're looking at things from the side view. And simply what we do is we cut through the ground with those virtual planes in red. So everything here, this one and this one and this one and this one, those are virtual planes. So we intersected the existing ground in black here with virtual planes. And then what we do next is we project the intersection between those virtual planes and the ground on a horizontal paper or horizontal plane. And so this intersection is simply my contour line, my contour line. The distance between those virtual planes, the distance, for example, every plane is at a given elevation. For example, the first one is 136 meter and the next one is 137, and it has to be constant. And you can see we're going 1 meter. And so this 1 meter interval, it has a name called contour intervals. Contour interval. We will talk in more details about contour interval later on, but please for now understand the contour interval must be constant. Must be constant. We cannot change the contour interval within the same drawing. Otherwise, there is no way for you to understand what's happening to the ground. So the contour interval must remain the same throughout the whole drawing or the whole map. As I said, we intersect those virtual planes with the ground, and then the intersection, we project the intersection into horizontal plane. And what we get is we get simply a continuous line. For example, when the virtual plane of elevation 140 intersect with the ground, this is the intersection. This line here is the intersection. So we call this line contour 140. We call the line by the same number as the generated planes. Okay, so this virtual plane intersect with the ground. So we take the intersection and we call this line is contour 140. Remember, contour line is all the points, all the points along this line, it has the same elevation. One more time, contour line, all the points along the line, it has the same elevation. And what does it mean? It means all these points, the elevation here is 140 meters. And again, what we do is we keep intersecting the ground with different virtual planes with constant interval, and I get this picture here. And I'm asking you, what if I hide this picture in the on the bottom? What if I hide? Remember, I start from here and I generate my contour lines. I'm asking you, what if we hide this elevation view? I'm asking you, would you able to kind of in your brain, would you able to visualize and understand what's happening in this area? Please do the following. Hide the bottom part and then look at only the contour lines and see, are you getting the same visualization and same understanding of the ground as what you get if we cut cross sections through the ground?
No.
Yes.
Those circles which the kind of getting smaller and smaller and smaller, that tells you that there is a big hole in the ground. And so you can see that there is only one contour line that has a label, which is 140. The other contour lines were left unlabeled, and I'll tell you how later on, not now. But you can see finally there is a spot elevation here, and the spot elevation, it says 135.93. It means my ground is simply going down in this area. And I think some of you already answered. Are you getting the same visualization, like understanding of the ground by looking at the contour line rather than creating a cross section?
Yes.
Okay, perfect. Now, this is, I think I'm gonna stop, like I'm gonna finish this slide and I will continue next class. This is just a training for you to understand how can we read contour line. The rules are so simple. The rules are not very difficult. Contour lines, let's look at the definition. Contour lines are produced by cutting the ground with virtual planes. Please look at this. So here you have a slope. So see this slope here, and here you have another slope. Just go back and look at how the contour lines are doing here and how the contour lines are doing here, and you will know our first rule. So our first rule is very simple. When contour lines are very well spaced, it means I have a mild slope. When contour lines are very, very close, it means, look at this, it means I have a cliff. I have a vertical, almost vertical side here. And we can apply this rule here. I'm asking you, where do you think in this map has the highest slope in this whole entire map?
Where the dark line is?
Look at this, please. I'm gonna, show you. Do we have the high slope here?
Yes.
Okay, you can see this is the area in your map that really has the highest slope. Okay, why? Because simply look at this. All the contour lines are very close to each other. And why do we need to understand the slopes are so high or so mild? Because this is tightly connected to your design. If you were to design a road, and the road will start somewhere here, okay? And from this point, and you want to connect this point to this point with a road. Can you just go with a straight line? Probably I need to show my marker, So here is my pen. I'm asking you, what if I have a little town here and I want to go with a road to this little town here? I'm asking you, should we simply go and then go with a straight line between the 2 points?
We need
Is that a
a
good idea?
need a bridge.
So you can see if I do so, what happens here, you can see I'm kind of climbing on top of the mountain and then going back. I think this is not a good idea because simply you will have lots of cut and fill. Lots of cut and fill. And to do a good job, what you do is you can make an alignment, and this alignment will simply avoid, and we can simply avoid this and simply turn around the mountain and then connect it to the other point. Please forgive me for the spikes. I don't know. Whenever I press hard on my pointer, it just makes a spike. So you guys can imagine that really the best idea is to avoid the topography, because we can see here there is kind of mountain here and go around. Also remember, when we move parallel to the contour lines, I'm asking you, what is the slope? If I move parallel to the contour line,
Consistent, like the same.
I'm asking about the slope. Do we have a slope if I move here? For example, I move this way.
Like the elevation's the same if you move along the same line.
Which means there is no slope. That means the slope is 0. So the minimum slope is simply parallel to the contour line, while if you move perpendicular to the contour line, the slope is maximum. The slope is maximum. Okay. One more thing I want to mention before we finish today: contour lines. When you look at my map here, I'm going to probably click here one more time, and I think I need to exit, discard. Now let's look at this picture here one more time, and please, do you see all the contour lines? Do you have a label? Do you see all the contour lines? Do you have labels?
No.
No. And remember, if I place a contour label on every single contour lines, what it does simply, it makes my map so dense, lots of text, and simply not good idea. And that's why in contours, we do not label every contour line. We only label few of them, because simply it's redundant. Let me ask you, you can see, for example, here, please look at my cursor. You can read the number. The number is 850. This is 850, huh? And this number is 875. I'm asking you, what if I write here 855, 860, 65, and then 70? What do you think? Is that redundant? Redundant, huh? It's extra.
Yes.
It's more than what you need. And that's why people a long time ago, they agree on, you don't have to label all the contour lines. You have to pick some of them and label them. And so that's why you will see here there is something called index contour, and there is something called or measure contour. Those are the only ones that we label them. And people like long time ago, they agree on one rule, and the rule is we label every 5th contour line. So what we do is we go 4 unlabeled, like 1, 2, 3, and 4 unlabeled, and then the 5th one will be labeled, and then we go 1, 2, 3, 4 unlabeled, and then the 5th one will be labeled. One more time, we label every 5th contour line. The ones that we label them, we call them index or measure contour, and the one that we do not label them, we call them minor contour lines. Minor contour lines. Okay, we're very close to end. Now, I'm asking you, what if I go here, okay, and simply you can see I have here of 900, and then here I have a contour line, and then I have here another contour line, and simply if I don't put here a spot elevation, so you can tell this is called spot elevation, which is 912.4. Let's say I omit this one, I delete this number and delete this number. I'm asking you, do you think you are able to interpret and read contour lines if I leave it vague? So my contour lines, we're going here from 875, we arrive here at 900, then nothing else. Would you be able to understand the ground in this area? I doubt, because you don't know whether the ground is going down from this point or still going up. And that's why in these areas here, we need to add something called spot elevation. And typically we do that at the summit. So when we have high area, we place here a label, and also I think this missing here, but also when we have a depression, we also must add here also add spot elevation as well. So at this point here, you must see a spot elevation. Otherwise, anyone who is reading contour line cannot read properly. Okay, this is really what I want to say for today. We still have a few minutes. Any question?
Sir, I have a question about assignment 1.
Okay.
So it says that it has to be in a group of 2, but is it really has to be in groups, or it's just one single individual submission?
Please, when I say group of 2, it is group of 2. And I know it's inconvenient for some of you. For example, some of you will say, you know what, I control my time. I can work midnight. I can work whatever I like. Okay. So some of you, for them, it's more convenient to work isolated and submit individual assignment. I understand that 100% because you need to find some time. You don't have to do that. Solve your assignment individually if you wish. And that's not my favorite way. My favorite way is take a study partner, a study buddy, and then solve it together. If you cannot, then what you can do is you can still pick another one, review your number together, come up with the best answer, and have only one submission. The thing is, guys, when we went online, we get isolated, which means you guys are everyone is in the office, in the room, don't see each other, and that's really a serious problem. Maybe some of you are not seeing this problem. When we have cooperation in class, students they tend to learn better because they learn from their classmates way more than they learn from instructors, for some reason. Okay, so really my intention is you guys cooperate, know each other. And then again, the bottom line is, if you even work on yourself, come with someone, review your numbers, convince each other which one is right probably in 10, 15 minutes, and then have one submission with both of your names on the assignment. Is that clear for everyone? I know it's more convenient. I couldn't find anyone. I'm off track. I don't know any one of my classmates. I will go ahead and I will simply submit individual. Please don't do that. For sure, it saves me some effort in marking. That's for sure. Something I cannot hide. But also, I can tell you, it will give you a favor. It will make you connect to your classmates. And remember, those classmates are the ones that you're going to make a capstone project. Those are your future workmates. Does it make sense?
Yes, thank you.
No problem. Okay. No time. We're done for today. So you guys have a fantastic weekend. Thank you so much.